Hey y'all, welcome back. Today we're going to continue our unit on graphing quadratics, and so far we've looked at equations that are in standard form, and we learned how to graph them using the vertex and finding other points that we can plot on the graph. But it's a little tedious to have to find the vertex every time by using that negative b over 2a and then plugging into the equation. It'd be a lot nicer if we could just pick out the x and y coordinate of the vertex directly from the equation. And so that brings us to what we're going to look at today, which is we can write the equation of a quadratic function in a different form rather than standard form. We can write it in a form called vertex form, where we can we can identify the vertex much easier. So that's what we're going to look at today. It's just a slightly different way of writing these quadratic functions as an equation, and I think you'll find that graphing them is much easier too, because finding the vertex will be much easier. So let's take a look at it. So last time we looked at standard form, which looked like this, right? It was f of x, or y, equals ax squared plus bx plus c. Right, and we talked about the different effects that A and C have on the graph. We didn't really get into exactly how B affects the graph, but we did learn how to plot quadratic functions that are in this form. So just to kind of reemphasize, A controls the width of the parabola, like makes it either narrower or wider. C will shift it up or down and is exactly the y-intercept. And then the overall strategy for graphing something like this is to identify the vertex by calculating the axis of symmetry, which is negative b over 2a, and then plugging that back into the function. And then we created a table to find more points. So that's basically what we did last time. So today what we can see is that if we have a quadratic function that's written a little differently, if it's written in this form, a times x minus h squared plus k, then the h and k is the vertex, and we don't have to do any separate calculations. So pretty nice to have that just embedded into the formula there. The axis of symmetry we don't have to calculate as negative b over 2a anymore. It's just literally h. So x equals whatever h is. Now I want you to be careful here, because the way this equation is set up is that we have x minus h, okay? So h will actually be the opposite of what you see in the equation. Like if you look at this example down here, you'll see it's x plus 2. Well, in order to get an x plus 2 in this formula, we would have to plug in a negative 2 right here, because x minus negative 2 is equivalent to x plus 2. So you just want to be real careful when identifying that h, that it will always be the opposite of the number you see in the equation. Now k, you don't have to worry about that because it's just plus k. So whatever k is, that's your k. So like if we look at this example here, the k is 3 and the h is negative 2. So I'm going to make that a point of emphasis as we go through all of these examples, but I just wanted to really point that out. So just to kind of summarize here, first of all, the a value that we had in standard form is the same as the a value here. So as far as how that affects the graph, it affects the graph the same way. So this value will control the width of the parabola and whether or not it gets reflected over the x-axis. So those are the same. The difference here is we don't have a b or c in the vertex form. Instead we have h and k. Okay, so the hk is the vertex. All right, I don't really need to write this separately because it's right there, but that is the vertex. So let's look at an example and just kind of show you how it makes graphing a little bit easier. We're still going to have to find points using that over-up chart that we did last time, but finding the vertex is going to be a lot easier. So, like in other words, in this case, the vertex here is going to be negative 2, 3. Okay, so just to identify my parameters here, a is negative 2, h is negative 2, okay, and k is 3. So the a I'm getting from right here, the h is right here, and the k is right here. So just to kind of point that out. So the vertex here is going to be -2, 3. The axis of symmetry is x equals -2. So let's go ahead and plot what we know here. So I'm going to draw the axis of symmetry, which again I'll do in a different color because it's not actually part of the graph. Or it's let me say the axis of symmetry is not showing solutions to the equation. It's just going to show you the midpoint of the graph. So let's see here. -2 would be right here. So there's a little axis of symmetry here. The vertex is at 2 or -2, comma 3. So that's going to be up here. Why is that not drawing? There we go. So -2, 3. Okay, so we know that the y-intercept here, we don't know that yet, right? We need to figure that out. So that's one sort of downside to this is with standard form, the y-intercept was c, but for vertex form, it's not as clear. So what we'll do is we'll just graph it, and then we'll see what the y-intercept is once we get it on the paper. Okay, so I'm going to create a little table here, my little over-up chart. Ooh, that's kind of wide. I don't need it that wide. So I'm going to make a little over-up chart. So if I go over, up, okay, so I'm going to, remember, I'm going to take the over, and I'm going to square it, and then I'm going to multiply it by a. Okay, so if this is x, then this is a times x squared. Okay, so starting from the vertex, if I go over 1, then I'm going to go up 1 times x squared, so or x 1 times 1 squared. No, I'm sorry. My a value is -2. My bad. -2 times 1 squared. Which would be -2. Okay, so in other words, if I start at the vertex and I move over 1, I need to go down 2 and plot that point on either side of the axis of symmetry. If I go over 2, then my up will be -2 times 2 squared. Which would be 4 times -2, which is -8. I don't believe we're going to be able to fit much more on there, but let's see where this ends up. So if I go back to the vertex, go over 2, go down 8, 1, 2, 3, 4, 5, 6, 7, 8. Plot that point, reflect it over the axis of symmetry. Now, just to kind of see where this would end up, if I go over 3, I would go up, and I use that word up a little loosely because you can see we're going down, but that's because our quote-unquote up is a negative value. We would have -2 times 3 squared. So 3 squared is 9, and 9 times -2 would be -18. We're not going to be able to fit that on here, but we would go back to the vertex, go over 3, and go down 18, which is going to put us way down here. So now I can draw my parabola and answer the rest of the questions here. Draw my little arrows here and do my best to make this a curve. Again, I'm not trying to make a V. I do want to show a little bit of curvature up there as best I can as I'm sketching that out. So there's our parabola. Now we can answer all these follow-up questions. So the y-intercept, we can see, is at -5. So that's 0, -5. The domain should be no surprise at this point. I mean, we've had a few days now where the domain is always all real numbers. And the range, nothing really new happening with that. So hopefully you've kind of mastered that by now too. It would be y is less than or equal to +3. So when we're trying to describe the transformations, this is also kind of a review of what we did last time. we've got a total of 3 transformations here. The first one is a shift to the left, so it's a translation, which is what shift basically means. Translation 2 units left. Then we have a vertical stretch, and by a factor of 2, okay. And then we have a reflection over the x-axis. And then finally we have a shift or a translation 3 units up. So we've got actually 4 transformations going on here. Look at that. Okay, so just to be clear, the translation to, you know what I should do? I think what I'm going to do here is I'm going to write out the equation here and just highlight what is causing each transformation, just to make it really clear. Okay, so I'm going to just copy this 4 times here, so I can highlight for each one of these transformations like what is actually causing that. And I don't think I'll do this for every single one, but at least one so you can see. I mean, this one is a really good example because it's got all these transformations. So I won't necessarily do this for every single example, but I think at least one should be good. Okay, so let's see how we're going to do this. I think I'll just draw a little circle around what's going on here. So the translation 2 units to the left is being caused by this right here, okay, because it's x minus -2. The vertical stretch times 2 is because of this value right here. Notice I'm not circling the negative because the negative doesn't cause the stretch. The negative causes the reflection. And then finally the 3 units up is, well, this one's pretty obvious, this one. Okay, so just wanted to highlight, what part of the equation is causing each one of these transformations. And maybe, it's not a bad idea maybe to do that one more time on the next one. But after that, I think it should be, I'm not going to show you this on every single problem. So let's look at another example. And that's pretty much it for today, is we're just going to do a few more examples of this, and that's it. And then you're going to practice graphing this vertex form on your own. So let's look at this equation and identify the vertex, which we can see is going to be +1. Recall that h is the opposite of what you see. So +1, comma +6 is going to be my vertex, which means my axis of symmetry is x equals 1. I'm going to draw the axis of symmetry, x equals 1. It's going to be right here. Just going to kind of help guide my graph here. And that's really all this does, is it kind of helps you guide the graph. It doesn't actually, these are not points these are not points in the solution set. So let's see here. Let's go ahead and plot some points now, or at least the first one that we know, which is this 1, 6 is right here. And now we'll generate our table. A little over-up table. Okay, so over and up. So again, to calculate the up, we're going to do 3 times the over squared. All right, so now if I go over 1, that means I'm going to go up 3 times 1 squared, which is going to be equal to 3. So starting from the vertex, if I go over 1, I'm going to go up 3. And you can see that's probably going to be all that we can fit on there, unfortunately. We're not going to be able to fit much more. And then if I go over 2, I don't think that's going to fit, but let's just double check. If I go over 2, I'm going to say 3 times 2 squared. And that's going to equal, 2 squared is 4, 12. So yeah, it's going to be obviously way off the graph. So that's all I can fit, no big deal. Let's go ahead and draw little arrows here. Draw a little happy face. Oh, okay, that's a little off. It looks kind of V-ish. I'm really trying to get that curvature. It's really kind of difficult with the mouse. There we go. That looks a little better. All right, now we're rocking. Okay, so there you go. There's the curve. And now we can answer the rest of the questions, like the y-intercept, which is 0, 9. We can identify that from the graph right up here. The domain is, once again, all real numbers. In fact, you could just like fill that in for all these problems. That's not going to be any different for any of these quadratics. And then the range is going to be all the y values that are at or above 6, right? This is the lowest, this is the minimum value is 6, so all the y values are above it. So let's describe the transformations here. We don't have the reflection, so we're only going to end up with 3 transformations. Particularly, we have a translation to the right. How did I word that before? Did I say right first? Or okay, so I said the units. So translation, 1 unit right. Then we have a vertical stretch by a factor of 3. And then finally we have a translation 6 units up. So I think it would be worth, at least for this last one, just highlighting where the transformations are coming from. Like I said before, I don't think we need to do that on every single problem, because once you see where the transformations are coming from, you know, they're coming from the same place every time. So I think one more should be probably good enough to where, well, I could just copy all this, probably easier. One more should be enough to really get that sort of the visual. And if you're not sure, you can always look back at these problems as examples to see where they're coming from. So the 1 unit to the right is being caused by this guy, the vertical stretch by 3. This one's a little bit more obvious because all the numbers are different, but just want to highlight that one more time. All right, so moving right along here. Let's see, let's box that. I don't think I boxed it up here. We'll do, let's do another example. Well, I think I've only got 3 more examples for you. Today's going to be a little bit shorter of a day. Example 3 is 1/2 times x plus 4 squared minus 2. So let's jump right into this. Our vertex, oh, not yellow. That's kind of hard to read. Our vertex is going to be -4, -2. Our axis of symmetry will be x equals -4. So let's go ahead and plot our axis of symmetry and our vertex on here. So -4 is going to be right about here. There's our axis of symmetry. And then let's try to make it a little more centered. There we go. It looks a little better. And then our vertex is at -4, -2, right down here. Oh, that's a little small. That's kind of hard to see. Let's make that point a little easier to read here. There we go. Okay, so my a value is 1/2. So as I go over, I'm going to square that over and then multiply by 1/2. Okay. You know, eventually I want to kind of get away from having to write the table every single time. I'm still going to do that for now, but you do want to try to get to a point where you don't really need it. So let's make a little over-up chart. If I go over 1, okay, so if I go over 1, then my up is going to be 1/2. So I'll just write it as 0.5 times 1 squared. So 1 squared is 1 times 0.5 is 0.5. It's 1/2. So if I go over 1, I'm going to go up 0.5 or 1/2. So let's go ahead and plot that first point on there, right in between here and here. So I go over 1, up 1/2. I just realized I didn't actually write the over up here. Okay, so this is my over, this is my up. All right, so if I go over 2, then I'm going to multiply 1/2 times 2 squared, which equals, let's see, 2 squared is 4, half of 4 is 2. So I'm going to go, if I go back to the vertex and I go over 2, I go up 2. Well, when this a value is a fraction, you'll find that you can fit a lot more points on there. Okay, so if I go over 3, then I square 3, which is 9. Half of 9 is 4.5, 4.5. So if I go over 3, 1, 2, 3, go up 1, 2, 3, 4.5. That's probably enough to get the general shape down here, but just because we can, let's do one more. Go over 4, go up 4 squared is 16, and half of 16 is 8. So I'm going to go over 4, 1, 2, 3, 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be a little off the grid over on this side. Just kind of estimate where that goes. And now we could draw our curve. Really wanted to get that last point also. I didn't realize that. Didn't really think about it until right now. But that last point is going to give us that y-intercept, so we kind of needed it anyway. Ugh. Struggling with this mouse drawing. There we go. Can I make it? Yeah, there we go. Okay, so my y-intercept is going to be 6, as you can see right here. So 0, 6. My domain, no surprise here, all real numbers. The range is going to be y greater than or equal to, there we go, -2. And let's go ahead and describe the transformations. I'm not going to go ahead and highlight all the different places because you can, I mean, this one's going to be pretty obvious anyway. But you can go back and look at the previous examples if you need a little bit more direction. So first we got a translation 4 units to the left. We have a vertical compression by multiplying our y values by 1/2. And finally we have a translation 2 units down. So those are our transformations. That's it for this one. So we're going to do 2 more, and then we're going to be done for today. So this next one, I just wanted to show you a couple where you may not see one of the parameters. So like notice on this one, you don't see the plus k. Okay, so we've got our a value, our h is +4, our k is kind of missing. And so what that means is that it equals 0. So I'll make a little note up here. Our a is 1/2. Our h is +4. Oops, not -4, but +4. And then our k is just 0. So it doesn't really affect too much. You just need to be aware that if you don't see that, it's a 0. Same thing with the k. Okay, so if you don't see a number here, if it's just x squared, then that's 0. And then if you don't see the a value, that's actually 1 because we're multiplying that, not adding it. So just something to keep in mind. Our vertex is going to be 4, 0. And our axis of symmetry is going to be x equals 4. You guys know the drill hopefully by now. You can kind of hopefully guess what's coming up. We're going to plot that axis of symmetry. And we're going to plot that coordinate, that vertex, 4, 0 is right there on the x-axis. Okay, so now our over-up table, actually we can copy what we had up here because up here our a value was 1/2. So our over-up table will be the same. Okay, so that's kind of the nice thing about this. Once you get, oh, I don't want that necessarily. I just want that. Okay. Once you do an over-up table for a particular a value, you shouldn't have to like recalculate everything. It's always going to be the same because the only thing that's really affecting it is the a value. Remember, the a value controls the width of the parabola. So as soon as you get 1, you don't have to redo it. So if I go over 1, I'm going to go up 1/2. We have that vertical compression behavior happening here. Over 2, up 2. Go back to the vertex. Over 3, up 4.5. 1, 2, 3, 4.5. And then over 4, up 8. It's not going to fit over here, but 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8. So it's going to be roughly right there. Let's draw a curve. You can see the y-intercept is going to be 0, 8. We'll write that as soon as I'm done drawing this. My domain is, of course, all real numbers. And my range is everything above 0. Once again, my y-intercept is 0, 6. Domain is all real numbers. And my range is y greater than or equal to 0. So to describe the transformations here, we've got just two. This time we've got a shift or a translation 4 units to the right, and we have a vertical compression by a factor of 1/2. No vertical translation here because we're not adding a k value. Okay, looking good, looking good. We got one last example problem here. Here's another one where you don't see the k value, and you actually don't really see the a value very well either, and this kind of goes back to what I was talking about before, where if you don't see a number there, it's assumed to be 1, and if all you see is a minus sign, then it's -1. So just to be very clear about what my parameters equal here, a is going to be -1, b is going to be, or not b, I'm sorry, h is going to be -2, and my k is 0 again. So my vertex will be -2, 0, so it's on the x-axis once again. And my axis of symmetry, what's going on here? There we go, is going to be x equals -2. So now, let's draw that line. And we'll draw the point. Let's make that a little bigger. Okay, so now we're going to do our little over-up chart. Now we haven't done one for -1 yet, so we'll just make a new one here. Oops. So my over, and so my up is going to be a, which is -1 times the over squared. So you always take that over and you square it. Oh, didn't like that notation. Let's try this. There we go. Okay, so if I go over 1, then I'm going to go up -1 times 1 squared, which is going to equal -1. So you can see this one's going to open down. Okay, if I go over 2, I'm going to go over 2 squared is 4 times -1 is -4. And then finally, if I go over 3, this, we're already off the grid here. So, but just to kind of show what's going on here, we get -9. All right, so if we go over 1, we're going to go up a -1, which really means down 1. So we've got that reflection going on. If I go over 2, I go down 4, which is already off the grid, so I'm not even going to bother with the next one. It's going to be way down over here somewhere. Let's go ahead and draw it. We now have enough information to answer our questions. The y-intercept, you got to be a little careful here because we are off the grid, but not by a lot. We can see it's 1, 2, 3, -4. And then my domain, shouldn't even have to say it at this point because it's been the same answer every single time. All real numbers. Our range is going to be all the values less than or equal to 0. So y less than or equal to 0. And then finally, we want to describe the transformations. So let's see here. The first one will be, let's see, we got to shift to the left 2. Okay, so we're going to translate 2 units to the left, and then we have a reflection over the x-axis, and that's it. All right, well, that's it for today. I hope you guys like this vertex form maybe a little bit better than the standard form. They both have their pros and cons. Where the standard form, you can identify the y-intercept directly from the graph. The real nice thing about the vertex form, that's why it actually has the name vertex form, is that you can see the vertex directly in the graph. It just takes away a couple calculations that you don't have to do where you did have to do with the standard form. You still have to figure out that over-up business to figure out exactly where to plot the rest of the points, but you have to do that either way. But that's it for today, and I guess I'll see you guys next time. Have a great day.